All right, Unit 10, Lesson 4. My favorite lesson, the bell curve. If you see below, you have a curve. And you know what it looks like? A bell, right? Remember those? That's what a bell looks like. Whether it's the Liberty Bell with our little ding dong, its little handle, or whatever. Well, the bell curve is a phenomenon of how things grow or how things are seen. So first off, let's see what all these numbers mean. Well, there's something down here you should recognize right away. It's the mean, the X with a bar above it. You have a new Greek letter. Looks like an O with a little tail on it. It's going to stand for deviation. It's the Greek letter for small sigma. There is a capital sigma, but this is small sigma. We're not going to worry about capital sigma. That means something else in math. So what is these sigmas and this average telling us? Well, this is how mathematicians look at everything. We find the average. Then we compare the object to how it fares against average. The object, or the data, could be one standard deviation above average. You can be two standard deviations above average. And then they go out to three standard deviations above average. And then we can break them down in between. You can be 1.5 standard deviations above average. Likewise, you can go the other way. It could be one standard deviation below average, two standard deviations below average, three standard deviations below average. So what does this all mean? Well, unfortunately, it's kind of like what everybody's crazy about these days, testing. Well, let's look at it in terms of sports. Here is your average sports. If you want to look at it as an ability, then we have our one standard deviations above average. Who would those kids be? Well, maybe those are the kids who make the varsity at a high school. This next second standard deviation that could be your college athletes, those who go on to play college. They're better than average. They're better than your average varsity player. And then right here, these could be our pro players. And then, well, what's left for right here? Well, these are your superstars, right? There's plenty of people who've made it to the pros, and you don't know their name, but we all know the superstar names. We know names like Michael Jordan and Tiger Woods and Phil Mickelson and uh, Matt Harvey. We know all those names. They're the superstars. But can we name every pro athlete out there? No, but they're definitely better than the average. And then likewise, we can go below average. So standard deviation is how far a piece of data deviates from the norm. Now we put percentages on these. And there's a lot of numbers being thrown at you right here. Notice this bell curve, we broke it down into halves. So one standard deviation below and one standard deviation above. And they called average is neutral here. 68% of a population is going to fall in between one standard deviation below and one standard deviation above. 95% approximately of a population is going to fall between two below and two above. And then we have pretty much 99.8% the entire population. So again, may seem a little confusing, but we're going to look at some examples to explain it. 13 kids took a math quiz. The following lists the number of correct answers on this 16-question quiz. So we're not looking at percentage, we're just looking at how many questions they got right. So we're going to plug this data into our stat list. Now notice something about this data. It's not in increasing order. When we did median, we put it in increasing order. Well, we're going to look at something different, so there's no need to put it in increasing order. We are going to go to our calculator. We're going to go to Stat. We're going to Edit, and we're going to clear out any old stuff, and we're going to type in our new data. 9, 9, 10, 11, 5, 10, 12, 9, 10, 12, 9, 16, and 10. We're going to go back to Stat again, just like before, and now we're going to calculate. We're still going to do our one variable statistic calculation. It's only on list 1. There is no frequency list. And now we're going to learn what all these other things mean. So I'm actually going to drag that screen out so I can write all over it. As you know, we have an average. So over here, we have our average of 10.5 approximately. Now, hey, that letter, didn't I just see that before? Yeah, that's capital sigma. And it means to sum up. So basically what it did was it added all together these numbers, 10, 16, 9, 12, 10, and it added up to 132. Now, back in the day when I was in high school, we had to figure out standard deviation by hand. It was a very long process. Not hard, but just long. And it involved squaring each piece of data and then adding it up. Now, the reason why we squared everything is because we wanted to find out above and below, and we were working with their distance. We didn't care whether the distance was below or above. Distance is never negative, it's always positive. So we squared everything to get a distance. Then, and don't have to do this anymore, but we wanted to see the average of those distances, and then we took the square root of it. But anyway, you get to look at a calculator. And there are 2 types of standard deviation, and they're listed right here. One is a capital S, and that's 2.48 when we rounded. And the other one is baby sigma, that's 2.38. Okay, so why are there 2 types of standard deviation? I'm going to remove this. This is going to tell you. It's very important that you understand the difference between these. S stands for sample deviation. This is when the data is information obtained from a sample of the population. The sigma, which looks like the letter O for population deviation, is when we use data and it's obtained from the entire population. All right, Up here, this math test. 13 students took a math quiz. And then we entered in 13 pieces of data. Was that part of the class? Or was that all of the class? As far as we can tell from this example, it's all of the class. So we would use a population deviation. Sample deviation is something like, well, let's say we wanted to survey something in the high school. We wanted to find out how many hours kids study. We would probably do a sample. We wouldn't be able to ask every single kid in Pearson High School how many hours they study every night. It just would take too long. So what we do is we would ask maybe 50 kids. See, we ask a sample, some of the kids, not all. Then we would use the sample deviation. All right, so now you're like, all right, Mrs. Trillin, I get all this. You plugged it all into a calculator and wham, out came these numbers. What do we do with these numbers now? We make a bell curve. All right, so I'm going to write down two little things here. First, our average was 10.15, and we are using population deviation 2.38. So now I'm going to construct a bell curve. All right, so the first thing I'm going to do is give myself a little base right here. Now I'm going to draw a bell to the best of my non-artistic ability. And if I were on the bell curve for artistic ability, I'd be down here because I'm a terrible artist. And then right in the middle is the average. So right there, the average is 10.15. Now my next line represents one standard deviation above average. That means if average is 10.15 and standard deviation is 2.38, I add that on. So that means this is 12.53. Two standard deviations above means I'm going to add on another 2.38. So two standard deviations above is 14.91. And then, yep, we went 3 standard deviations above, and that's generally where we stop. 14.91, add on one more standard deviation. It's 17.29. Now we're going to go the other way. We're going to go below. So I think by now you kind of understand what's going to happen on the below. You still may not understand what this is all about, but you're like, all right, if I added when I went this way, obviously I'm going to subtract when I go this way. So one standard deviation below means I subtract. And you get 7.77. I'm going to subtract one more. So two standard deviations below, it's 5.39. Subtract one more, and we get 3 below. 3.01. All right, so you're like, okay, it's the bell curve. I did the numbers. I added, I subtracted. Well, what does it mean? Well, let me go back and grab those scores for a minute. So here are those scores. So guess what? When you get to college, so many professors are going to grade on what's called the curve. And I'll tell you a story about the curve, but tomorrow in class. Remind me and I'll tell you about it. So the professor looks at this, and he is going to base your grade on how you compared to the rest of your class. not how you compared to a standard A is a 90 and above, B is an 80 to an 89, but compare you to your peers. That's how the SATs are done too, people. So for example, maybe this professor will say, since this is average and 68% of the country is average, then anybody who scored between a 7.77 and a 12.53 will get a C. Anybody, okay, block that off in blue, anybody who scored from higher than a 12.53 to 14.91, well, we're going to give those people the B. And then, if you scored above a 14.91, we'll give those people the A. Likewise, we'll go backwards. You people will get the D, and these people will get a failing grade. So now when you look at this, you say, these people who got a 9, they get a C, they get a C, they get a C, they get a C. Oh, this guy who got a 5, well, let's see, a 5 is a D, 10 is a C, 12 is a C, 9 is a C, 10 is a C, 12 is a C, 9 is a C. 16, there's our 1A, and 10 is a C. Because according to the bell curve, the vast population is average. This goes for height, goes for weight, goes for, let's see, this is how they grade you. Your SATs, I told you, are based on how everybody who took the SATs in that setting compare to each other. So if you got a 500, SATs are based on up to 800. That's how you compare to everybody who took it. A 500 in 2015 might not be the same score really as a 500, in 2014. It's based on the peers. Welcome to the bell curve.